Initiatives. India's National Security Advisor Ajit Doval met UK's National Security Advisor Tim Barrow in London yesterday. United Kingdom's Prime Minister Rishi Sunak also joined the meeting.
Hello guys, welcome to today's tutorial. So we will be designing a simple radio using some basic communication theory. So in this tutorial, we'll be learning about the design of a simple radio which will work for the frequencies varying from 80 megahertz to 108 megahertz. So the first part in any communication system is antenna. So we will be using a monopole antenna in this circuit or any wired antenna. Later on, for detection of the frequency in the circuit, we will be using a Colpitts oscillator which comprises of a air core inductor along with capacitance. So here in this circuit, the internal capacitance of BF494 transistor will be used as C2, and a variable capacitor varying from 0 to 22 picofarad will be used as C1. And we also have an inductor in our Colpitts oscillator, which will be the main part of a Colpitts oscillator. When it comes to Colpitts oscillation calculator, the formula for frequency is given by 1 by 2 pi root L Ct, where Ct is the total capacitance that is given by C1 into C2 divided by C1 plus C2. After calculating the frequency and inductance along with the capacitance, we get inductance value as 4 turn 22 SWG 4 mm dia air core, and based on the calculations, we have a 22 picofarad trimmer, that is variable capacitor, which is suitable for BF494 transistor capacitance. So the output of this capacitance is further given to transistor T2, that is BF495, which is a mid-range frequency transistor. So at BF495 output, we'll have output at R1, which is 10 kilo ohms resistor. At that point, we will try to construct a resonant circuit which allows a specific frequency to be detected. So after the calculations of resonant circuit, we'll get two capacitance C3, capacitance C3 as 100 nanofarad and capacitance C4 as 100 microfarad. Capacitor C4 will be electrolytic one. The output of transistor BF495, which contains the signal information, is given to LM386 amplifier IC. It's an audio amplifier IC with a coupling capacitor of 220 nanofarad along with a 10k ohm resistor to limit the signal. So we have used a variable resistor or varistor or a logarithmic pot of 22 kilo ohms, which will be used as a volume control knob in the circuit. As given in the datasheet of LM386, we'll be carrying out all the necessary connections as designed in the circuit. Later on, when it comes to the next part of the circuit, the output of LM386 IC is fed to a speaker with a coupling capacitor of 220 nanofarad. We also used a 100 microfarad capacitor which acts as a filter to regulate the power supply without any fluctuations in the circuit. DC battery voltage of 6 volts to 9 volts can be given to the circuit. So in a brief, this will be the complete circuit after the design. The Colpitts oscillator acts as a detector in the circuit, and these signals which we got from Colpitts oscillator will be fed to BF495 mid-range or radio frequency amplifier. At that point, the amplified output at BF495 terminal will be given to audio amplifier LM386. So the audio amplifier will amplify the given input signal and it gives the output on the speaker. So in the entire circuit, the variable capacitor, which is of 22 picofarad, will act as a tuning point where we decide the frequency that the oscillator is going to detect. So that's all for today. Any doubts and comments can be written down in the comment section. Thank you for watching. Please subscribe the channel. Further working videos will be given in the description. Thank you.